Okay, we talked about section 8.1 on Monday over proportions. We're going to skip 8.2 and move on to section 8.3 with more similar polygons. So what we're going to do is use polygons and proportions, and use proportions to help solve for missing side lengths on polygons. So first, what are similar polygons? Similar is a little bit different from congruent. Similar means they're similar in their shape, but they're different sizes. So these are same shape, but different size. And their sizes are actually going to be proportional. So if two polygons are similar, what must be true? The two things are corresponding sides are proportional, and the corresponding angles since they're the same shape, the angles are congruent. So if I look down at example 1, side AD is proportional to side EH. AD is double EH, so they're proportional. The angles, angle A is congruent to angle E, so corresponding angles are congruent. So let's look at example 1. It says, use the similar figures below to answer the questions that follow. What must be true about the angles? Well, these corresponding angles are going to be congruent. So angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. So all of our corresponding angles are congruent. So B, what must be true about the sides? Well, the sides are going to be proportional. Just like I said before, side AD is proportional to, and I'm going to use semicolon just to show that they're proportional to each other. So AD is proportional to side EH. Side AB is proportional to side EF. Side BC is proportional to FG. And side DC is proportional to side HG. And I put my line segment symbols because they're line segments. So scale factor would be, how are they proportional to each other? What's the exact measure that tells me that they're proportional? So if I use my scale factor from small to big on example 1, I could say 10 to 5. And my scale factor, if I reduce that, would be 2 to 1. So my scale factor would be 2. If I were going the other way, I could say 5 to 10 or 1 to 2, and my scale factor would be 1/2. But the question will specify which order it wants it to be. So scale factor is just the difference between your two polygons, how they are similar. So it's an exact number of how the sides are proportional. Okay. Let's look at our next example. My iPad is being slow, so give me just a minute. Okay, example 2. What is the scale factor of quadrilateral ABCD above 2 quadrilateral EFHG above. So if we find the scale factor with our ABCD first over EFHG, when I write my ratio, this time I'll write it as a fraction. So I just picked a side, AD, that was 10, just like I said before, and that corresponds with side EH, which is 5. So if I reduce that, my scale factor is 2. So that means quadrilateral ABCD is twice as large as quadrilateral EFGH. On example 3, it says, show that the ratio of the perimeters is the same as the scale factor. Well, if we find the perimeter of quadrilateral ABCD, we would add 10, 5, 8, and 6 together, and that would be 29. And then the perimeter of quadrilateral EFGH is 5 plus 4 plus 3 plus 2.5, which is 14.5. So if I take 29 and then I divide it by 14.5, that is 2. So how does the scale factor relate? So on example 4, it says, what is the scale factor of quadrilateral EFGH to quadrilateral ABCD in example 1? That's flipping it. So I would just say 1/2. So if it wants EFGH to ABCD, that would be, if I choose my sides that I used up here, 5 to 10, so that would be 1/2. Now make sure that you know that scale factor and the ratio of perimeters are always the same, just like you see here. They're both 2. Okay, on example 5 it says determine if the figures are similar and justify your answer. So if they are similar, that means the sides are going to be proportional. That's one part of it. So I'm going to prove that. If I just choose 2 corresponding sides and make a ratio, 9:6, that reduces to 3/2. I'm going to see if the rest of the sides are also 3/2. These are because it's just 3/2. If I look at the last pair of sides, 18 and 12, those are both divisible by 6. 18 divided by 6 is 3. 12 divided by 6 is 2. All of these sides are proportional, so yes, they're similar for that part, but I still need to check the angles. So I know that we have a right angle and we have an angle of 37 degrees. Remember, all angles inside a triangle should add up to 180. So if I take my 90, 37, add that together, that's 127. If I take that from 180, I get 53 degrees, which is the same as this angle over here. So if they both have a right angle, they both have angles of 53 degrees. That means this angle must be 37 degrees. So by angles, yes, they're similar. So, yes, they are similar. And similar, you can just use one squiggly. It's kind of like congruent without the equal sign. My justification is all of this work that I showed you guys. The angles here, all of the proportional side lengths, all of that is your justification. Okay, on example 6 we have similar figures, and we have to answer these following questions. Remember, the one squiggly line means similar, this one right here. So it says quadrilateral EFGH is similar to quadrilateral. If we put E first, we're going to put A first on the second one. F, then we're going to put B. G, we're going to put C. H, we're going to put D. The scale factor, it doesn't tell me what order to put it in, so I'm just going to pick an order. I'll do HG over DC. So my scale factor, 10 over 2.5, which if I reduce that, that would be 4. So my scale factor is 4. That means the second quadrilateral EFGH is 4 times as large as ABCD. Now obviously it's not drawn to scale, but they give us side lengths. So now we have to find the following, X, Y, and Z. In order to find these, we're going to have to set up proportions like we solved yesterday, or on Monday. So for X, if I'm looking at, I already set up a ratio for my scale factor. I did 10 over 2.5. So if I'm looking for X, it corresponds with EH, which is 12. So if I put 10 over 2.5, I did big to small quadrilateral. So I need to continue that when I set up my proportion. So I'm going to do 12 over X. Now when I solve, I cross multiply. So I have 10x when I cross multiply here. 12 times 2.5 is 30. So I have 10x equals 30. Divide by 10. X equals 3. So I found X. I'm going to do the same thing with Y and Z. And I can keep my 10 over 2.5 for every single proportion I set up. So 10 over 2.5 equals, now I'm going to solve for Y. So Y goes with 3. Y over 3. So that would be 30 equals 2.5 Y. When I divide 30 by 2.5, I'll find my Y, and that will be 12. So Y equals 12. Okay, when I find my Z, same thing, 10 over 2.5, but now I'm using 5 over Z. So that would be 10Z equals 5 times 2.5, which is 12.5, divide by 10, so Z would be 2.5, 1.25. Okay, this is the last part of the assignment on example 9. It says if the lengths of the sides of a triangle are in the ratio 3, 5, 7. So I'm just going to draw a triangle. I'll put 3 on the smallest sides, 5 on the second, and 7 on the longest side. I also know the perimeter is 120 centimeters. It's asking me to find the length of the shortest side of the triangle. The way that you need to do this is add up all of your ratios and put an x next to them. So 5x plus 3x plus 7x would be 15x. If I set all of those equal to their perimeter, which is 120, I'll be able to figure out what x is divided by 15. So 120 divided by 15 is 8. So if x is 8, now I can figure out, with my ratios, how to find the length of the shortest side. Shortest side is my 3x. Well, I know x is 8, so 3 times 8 is 24. So my shortest side is 24 centimeters. And you could keep going to plug in for your other lengths. Okay, on this one it's talking about a triangle's angles. So the measures of the angles of a triangle are in a ratio of 1, 2, 3. So we'll just call this 1, 2, and 3. Find the measure of the largest angle. It doesn't give me a total, but I know that all of the measures inside of a triangle equal 180 degrees. So I can use the same concept as last time. Put an x behind each one. 1 plus 2 plus 3 is 6. So 6x instead of equal to my total degree. Divide it by 6, and that will give me my x, which is 30. We need to find the measure of the largest angle, which is our 3x. So 3 times 30 equals 90. And this is a degree, so this was actually a right triangle. And that is my final answer.